All right, 6-2, day 2, solving systems by substitution. When you take your EOC and they give you systems problems, the majority of the time they are going to be in word problem format. There are two main types. We are going to go over the first one on the front, which will be with today's assignment, and then we'll go over the other type on the back, which will be with your Thursday Alex activity. All right, so on the front, these questions will ask you how many of each type. Okay, and again, this goes with today's assignment. And today's assignment is on paper, and you will have to show all of your work as I show you in your notes. Okay, so first thing we're going to do is we're going to mark up our text as we read it. So a town ordinance defines an adult tree as having a diameter greater than 10 inches. So we have adult trees. And a sapling, so we have sapling trees, as having a diameter less than 10 inches. All right, so we've got these adult trees and these sapling trees. Got it. Next sentence. The ordinance requires that on a new build project, okay, you get 2 new trees planted for each adult tree that fell, all right? So you cut down an adult tree, you got to plant 2 more in its place. Got it, got it. And you have to plant 6 new trees, all right, for each sapling you cut down. Okay, so far so good. Let's keep reading. All right. It says last year there were 167 trees that were cut down. All right. And then what else we got? We have got the community planted. Okay, planted 742 replacement trees. All right. How many of each type were cut down? Okay, so we're going to define our variable, and to define our variable, we are going to look at the subject. Okay, so what are we talking about in this whole thing? Well, we're talking about our 2 types of trees. We got our adult trees and our sapling trees. So those are your subjects of this little word problem. So we are going to use those to define our variables. So x and then y, okay? This is step 1. We're going to define our variables. All right, so adult trees came first, so that goes with x, adult trees. And then saplings came next, so that is our y, sapling trees. Okay. So this is your subject of your problem. Okay. So you define your variables with the subject of your problem, and our subjects we have adult trees and sapling trees. All right. So what action happened with the subject? All right. So what action happened with these? Okay, what is your action? And whatever action happened is going to be your equations. All right, so let me see, our actions are here. 167 trees fell. Okay, so we cut down 167 trees. Got it, okay. So 167 trees fell. All right, so we cut down 167 trees. All right. This doesn't talk anything else. We have no other information besides for the trees that we cut down, except for the total, okay? And we know we cut down adult trees and sapling trees when we were clearing the land. All right, so no other information, so we are just going to use x and y. Right? We cut down some number of adult trees plus some number of your sapling trees. In total, we cut down 167. All right, well, we're doing a system, so we need to have another equation because we actually have another action. All right, what is our second action? Our second action is planting, replacing the trees. All right, so the community planted, all right, we planted, all right, 742 trees. Okay, that's our action. We planted those. All right, well, we do have more information about our planted trees. We know we planted 2 new trees for each adult tree that fell. That's my X. All right, so 2X. All right, and then we know we planted 6 new trees for the saplings. That's my Y. All right, so we have our 2 action equations. So this first one is cut down trees. Okay, that was the action for this one. And this one was planted trees. Okay, so we had a little story. We had a subject of that story, and we had action of that story. Okay, the subject gives you your variables that you define. Okay, and then the action gives you your equation. All right, now defining your variables and making sure you have your systems set up correctly, most important thing. All right, we can do the systems. The math itself is fairly straightforward, and we're practicing it a lot, and we're getting really good at it. So making sure you have your systems accurate is very, very important. All right, so just like yesterday, we are going to isolate one of our variables in order to substitute what it equals into the other equation. Now, the cut down equation looks like it is the easiest because it has 2 variables that have one as a coefficient, so we can isolate either one. I am going to isolate X. You could isolate Y. All right, you could do that all day long. I'm just going to isolate X. So let's isolate X. Okay, so I'm going to rewrite it up here. So X plus Y equals 167. So I'm going to isolate X. I always circle what I'm isolating. All right, outside of that, we're going to subtract Y on both sides. And we end up with X equals 167 minus Y. Okay, so we have what X equals. Since we used our cut down equation to revise the equation to get one of our variables isolated, we're going to use our other planted equation in order to substitute. So we are going to put in what X equals in for X. All right, so we have got 2. And what does X equal? Well, 2 and X are multiplied, so we're going to put this in parentheses. 167 minus Y. All right, plus 6Y equals 742. So all we did was we took this equation and we substituted out what X equaled. Okay, now that we have our parentheses, we are going to distribute. We're going to multiply this one by 2 and that one by 2. So 2 times 167 is 334. 2 times negative Y is negative 2Y. And now that we've distributed, we just write the rest of our equation. Plus 6Y equals 742. Now on this left side, we have 3 terms. 2 of them are alike. All right, so that's the minus 2Y and the plus 6Y. Remember, the sign goes with the number behind it. So let's combine these like terms because they are on the exact same side. So we're going to bring down that 334. And then minus 2Y plus 6Y, well, that is a positive 4Y. And that equals 742. Hey, we've got ourselves a 2-step equation. Let's isolate Y. minus 334 on both sides. That gives me 4y equals 408. All right, my last step is I'm going to divide both sides by that 4 to give me y equals 102. All right, we have found out what y equals. Okay, now let's find out what x equals. Now we're going to use our revised equation because we already have x isolated. Okay, that is our other equation. And we are going to substitute in 102 for y. So we've got x equals 167 minus, well, what is y? 102. All right, let's solve for x. X equals 65. All right. So solving for your first variable, then we solved for our second variable. All right, so now that we have both of our variables, okay, word problem, so our answer needs to be with words. So what is 65 talking about? Well, let's see, how many trees of each type fell? All right, so X, adult trees, and we got 65. So 65 adult trees fell. All right, and then y. Y equals 102, and y is your sapling trees, and it's asking how many of each type fell. So 102 sapling trees fell. Okay? And that would be, I guess, step 5. There we go. So we have our 5 steps. First, we're going to define what our variables are. That's your subject of your problem. And then we are going to write our systems. Step 2, that is the action of your problem. Okay, 1 math sentence for each. You cut down, and then you plant it. And then we solve for 1 variable, and then we solve for the other. Actually, I misnumbered. So this is step 3 and 5, because we came back to it. So that would make this one step 4. And this one's step 6, and I'll tell you why. Okay. So step 1, step 2. Okay. Step 3, we isolated one of our variables. Then we solved for the variable, and then we used that back into the equation that we isolated the variable. So I guess that would make this step 5 here. Okay. Found our other variable, and then step 6 we label. That's a lot of different steps. We take it slowly, all right? But these are the 6 steps I want to see, all right? So let's try this again. Okay, let's try this again. All right. So geometry, we have Kamani has 2 equal-sized large pitchers and 2 equal-sized small pitchers. All of the pitchers together hold 40 cups of water. The capacity of 1 large pitcher minus the capacity of 1 small pitcher is 12 cups. How many cups can each type of pitcher hold? Okay, that was a whole lot of information we just got. Okay, so we have 2 equal-sized large pitchers. Okay, so we've got 2 large pitchers, and we've got 2 equal-sized small pitchers. So we got 2 large and 2 small. That's 4 pitchers all together. Okay, that's what our first sentence told us. And then all the pitchers together hold 40 cups of water. Okay, so all 4 pitchers all together hold 40 cups of water. Okay, so far so good. All right, let's keep reading. So the capacity of 1 large pitcher minus the capacity of one small pitcher is 12 cups. Okay, what's it looking for? How many cups can each type hold? All right, well, first up, what's our subject? Well, our subject is the pitchers. We got large pitchers and we got small pitchers that we're talking about. So let's define our variables. Okay, x, y. All right, the first thing we came across were large pitchers. So we're going to make x equal large pitchers because that's our subject. Pitchers. And then y is the small pitchers. All right, so we defined our subjects. Those are our variables. All right, 2, let's figure out what action we have with these pitchers. All right, the pitchers are holding water. All right, so together, so we are going to have all pitchers. Okay, so all of the pitchers all together hold 40 cups. Okay, so all of your pitchers hold 40 cups. All right, so what does it tell me about my subject? Well, 2 large pitchers, okay, 2 large pitchers, plus 2 small pitchers, okay, together hold the 40 cups. Okay, so all the pitchers hold 40 cups. Okay, cool. What else we got? Well, then we have this sentence, okay, that literally reads like a math sentence. All right, so the capacity of one minus the capacity of the other is 12 cups. So we're talking about 1 minus the capacity of one minus the capacity of the other. Okay, so the large, small. Okay, so all the pitchers, and we're just talking about one of each. So one large minus one small is 12. Okay, that was straight up a math sentence. All right, and we want to know how many cups each type holds. Okay, well, it looks like if we take the large small, we can isolate one of these variables. You can isolate either x or y. I'm going to actually isolate y in this case just to bring up a point of when we have a minus y, just so we can practice that skill and see that skill one more time. So I'm going to write it up here. X minus y equals 12. So I'm isolating my y. Okay, circle what I'm going to isolate, minus x. The negative goes with what's behind it. That's y equals 12 minus x. All right, you can do one of 2 things here. Now, a lot of people in class want to multiply the whole thing through -1, and that's perfectly fine. I divide by a -1 simply because if I was doing any other math at this point, I would be dividing, because currently -1 is multiplied by y already. We are just literally changing the sign, so the math still maths either way. Okay, so this is going to change the sign of everything, so that gives me a positive y equals a -12 plus x. All right, making sure you change the sign of absolutely everything is vital. This skill here is one of the reasons a lot of people were graphing wrong on number 6 for Monday's assignment. Okay, so definitely wanted to revisit that skill. So this is what y equals. And since we used the large small, we're going to use the all pitcher equation to put y into here. Okay, So that gives me 2x plus 2. Well, 2 is multiplied by y, so we're going to put that in parentheses, what y equals. Okay, and that equals 40. So again, all we did was we took this whole equation, okay, the whole equation, we took y out and put in what y equals here. We substituted. So now we have one set of parentheses, so we're going to distribute that plus 2 to both. Okay. So we have got 2x. Oh, we're doing nothing with this 2x. Okay, 2x. All right, plus 2 times a negative 12, that's negative 24. Plus 2 times plus x is plus 2x, and that equals 40. Now we look over here on the left, and we have 3 terms, okay? 2 of them are alike. These 2 here both have x's, okay? So 2x plus 2x is 4x minus 24 equals 40. Now I have a basic 2-step equation that I am going to solve. 4x equals 64. Last step is to divide both sides by 4, and x equals 16. Okay, we've got x equals 16. We need to solve for y, so we're going to go back to this equation here. Okay, so this was step 3. Right, nope, this was step 3 here. See, this is what happens when you don't number along the way. This is step 4. All right, we're going to use this equation. That makes that step 5. We're going to use this equation. So let's use this equation here and put in what x equals. All right, x equals 16. We're going to put that in right here. Okay, so the equation itself is y equals negative 12 plus the value of x, which is 16. Okay, y equals 4. All right, now we know what x, we know what y is. This is a word problem. What was it asking me? Well, it was asking me how many cups can each type hold. So we're wanting to know how many types. So the large pitcher holds, that's x, 16 cups. And then y are small pitchers hold 4 cups. Okay, so small pitcher holds 4 cups. Large pitcher holds 16 cups. All right. So that is our how many of each type problems. Okay, this was step 6 here. All right. So those are on today's assignment. Today's assignment is a paper assignment. You're going to practice on 4 of these. Now let's go on the back and let's talk about what will be on tomorrow's activity. Okay, these are different type of problems. These answer the question, when will your 2 items be the same? Okay, and this is on tomorrow's activity. Okay, now with these, when they will be the same, you're going to use your equation y equals mx plus b, and we are going to define what y equals, what m equals, x, and b. Okay, we're going to define what each of those 4 variables mean, and then we're going to have our 2 different equations. Okay. So 2 ride-sharing companies charge customers a base fare, okay? They charge a base fare and then an additional fee per mile. Per mile. Per is an important little word there. All right. So our y equals mx plus b. Y, in this case, is total cost. Y is always going to be total anything. Whatever it is that you're looking for, y is the total of it. And in this case, it's cost, because we're talking about money. Okay, when you're looking at these, m and x are your easiest to find. They're always together, because you'll notice in the equation, they are right next to each other. And typically, m is before the word per, and your x is going to be after per. All right, so what comes before the word per? Well, it's your additional fee. All right, so it's money. Money per what? Money per mile. All right, so x is your number of miles. And then what is b? All right, well, we already have all of this. We have the additional fee per mile, but what also do you pay? Your base fare. All right, that is what you pay no matter what. It does not change. It is not variable. That is what you pay as soon as you sit your butt in that taxi and tell them to go somewhere. You are paying that base fare whether you go 5 miles or 50, okay? Doesn't change. So now that we know what each of these are and how to find them, okay, look for the keyword per, find your MX first. Let's keep reading. So we have two companies. We have the Ride Around company, and they charge a base fare of $3 and $1.75 per mile. Okay, and then we have our Cargo. All right, they charge a base fare of $7 and $1.25 per mile. Write a systems of equation. Okay, so let's write these systems. So we're going to have a ride around equation. All right, so in the y equals mx plus b, y is your total amount. All right, m and x, money per mile. Money per mile. $1.75x. And then plus b. B is your base fare. Their base fare is $3. Okay, now let's talk about our Cargo. Cargo. They get their own equation. All right, so they charge a base fare of $7 and $1.25 per mile. Y is their total cost. MX, dollars per mile, $1.25 per mile, plus their base fare. Their base fare is $7. Now we have our two equations. They equal each other, okay? So we talked about this when we did our assignment yesterday because they equal each other. They both equal y. We can set them equal to each other, okay, because they both equal the same thing. So $1.75 per mile plus $3 base equals $1.25 per mile plus $7 base. All right, now you have 4 terms. All right, we need to get all of our x's on one side, our terms without x's on the other. You can do this a couple different ways. You can move any of them. I always move the lowest valued variable first to guarantee I'm not dealing with negative numbers when I can avoid it. All right, so we're going to move the $1.25 per mile. We're going to subtract it from both sides. Okay. That gives me 50 cents per mile plus 3 equals 7. Now I just have a 2-step equation. So let's subtract 3 from both sides. And you got 50 cents per mile equals 4. Last step, divide by 50 cents. So how many groups of 50 cents can you make out of $4? Well, you can make 8. So we know what x is. Now that we know what x is, let's solve for y. Now, we learned yesterday that we can use either of these equations, all right, because they're both set to y, and we used both of them. So if you use both of them to solve for one variable, you can use either one to solve for your other. I am going to use my first equation, y, just because I picked it. No particular reason. You could choose your other one if you want to. Go on. All right, so y equals $1.75. And what is my x? My x is 8. My x is 8. All right, plus 3. Plus 3. Y equals, well, that would be 14 plus 3, and that equals 17. So let's answer the question that it originally asked me. It says write a system equation for the scenario to determine when the cost will be the same. All right, so when is the cost the same? Okay, so x is number of miles, y is total cost. So at 8 miles, because we always talk about our x's first, okay? So at 8 miles, the total cost, that is what y is. Total cost is in money, so $17 is the same for both. Okay, we have answered our question. Knowing what your variables mean is important, because if you don't know what the variables mean, the state will try to trick you, and they will try to have you solve for x, y. Cool, but if you don't know what those mean, you could say 17 miles for a cost of $8 because you haven't defined your variables. Okay, defining your variables are very important. All right, let's practice that one more time. Let's practice that with giraffes. All right, so we are going to answer after how many days will the two giraffes be the same height? Okay, we're talking about our giraffes. So we have two different types of giraffes. We are going to have our equation y equals mx plus b because we want to know when they are the same height. Okay, so we're going to define our y, our m, our x, and our b. So giraffes stand about 6 feet tall when they are born. You don't need that in your actual problem. That's just random knowledge. Sometimes the state will give you random knowledge just to let you know, hey, giraffes are really tall when they're born. So we've got a male giraffe. He is born at 5.7 feet tall, and he grows, okay, 1/12 a feet per day. And there's that little per word. Okay. Then we get into the female giraffe. All right, let's talk about what our variables are going to stand for. Well, we're talking about height. So y is always total, whatever it is you're talking about with these. So we're talking about total height here. Okay, we're going to find the mx by looking for that word per. Okay, m comes before the word per. So per, grows 1/12 feet. So grows. So how much it grows? Grows per what? Grows per day. So number of days. And then, okay, we've talked about this. Well, then what's B? What doesn't change? Starting height, okay? This one's starting height is 5.7, so starting height. Okay, your starting height is, well, whatever your current measurement is. And your starting height, not going to change. Well, it is. You're going to grow taller, but that's the point of this, is to find your total height. But we have a starting height. We aren't shrinking. Okay, this is our starting point. Okay, so let's talk about our male giraffe since we've already underlined him. So we're going to have a male giraffe, and the male giraffe is y equals, well, let's find mx, let's find that word per. All right, how much do they grow? 1/12 per day. Okay, we've already talked about this. Their starting height, 5.7 feet. All right. Now let's get on to our next one. We got a female giraffe. Okay, that's our next subject. They were born a few weeks ago. Cool. And the female giraffe is 6.8 feet. Okay, that's our starting height. And grows, okay, 1/16 per day. Hey, there's that little per word. All right, and I even told you X is the number of days and Y is the total height of the giraffe. Okay, we already defined those. So we've got our female giraffe. That is our other equation. All right, the female giraffe, total height equals, well, their growth per day is 1/16 per day, plus what is the female giraffe starting height? We're going with 6.8. All right, awesome. Okay, so we have our two equations. We can set them equal to each other. So 1/12 x plus 5.7 equals 1/16 x plus 6.8. All right. Normally at this point, we would subtract the lowest, I would subtract the lowest term with the variable, but currently they are not like terms. All right, so the common denominator, because that's what you have to find when you are adding or subtracting fractions, you have to find the common denominator. The common denominator for 12 and 16 happens to be 48, okay, 48. Yeah. 48x plus 5.7 equals, this one is going to be in reference of 48, x plus 6.8. All right, so we would multiply 12 times what to get to 48? Multiply that by 4. If we multiply the denominator by 4, got to multiply that numerator by 4. And then 16 times 3 gets you to 48. Multiply the numerator by 3. All right, now we have common denominators. Now we can subtract 3/48 x from both sides. Because, you know, in real life, you don't always have pretty nice numbers to deal with. Sometimes you have fractions. That gives me 1/48 x plus 5.7 equals 6.8. Okay, let's isolate our x. So we're going to subtract 5.7 on both sides. 1/48 x equals 1.1. All right, now in this stage, we would typically divide by the number in front of x, except for it's a fraction. You cannot divide by fractions, so you multiply by its reciprocal, or in this case, we're going to multiply both sides by 48. Okay, that gives me x, and I highly suggest, based on the answers that were given in class, use your calculator. Okay, 1.1 times 48 is 52.8. Okay. We did all of that. We have found our x. Now we need to use either of our equations. You can use either the male equation or the female equation. The math will math the same at the end, okay? Does not matter. I always just usually choose my first equation, which happens to be the male equation. So we are going to substitute in 52.8 in for x. So y equals 1/12. All right. Now you can change any fraction, any whole number into a fraction by putting it over 1. Okay. Plus 5.7. Y equals. All right. So 52.8 divided by 12. Okay. Put that in your calculator. And then add 5.7. When you do that in your calculator, you end up with 10.1. Okay, so we have our x and we have our y, and what's it want to know? It wants, after how many days will the two giraffes be the same height? All right, so x is 52. 2.8, and y is the height. So let's answer the question. So after 52.8 days, they will both be 10.1 feet. Okay, so we have answered the question. All right, so again, and be the same. These types of problems will be on your activity that you do tomorrow. The activity tomorrow in Alex, you will need these notes. You will need your notes from Monday. You need your notes from Tuesday. All right, good luck.